So, okay, guys, this is 2013, right? So, 2013 past paper. So, using the special method, it's better to do. Here, we'll do this. Okay, guys, this is special method. So you have to be very technical. As I told you, if anything like this, if denominator here square and here square, you always take a rough paper and check with difference of these squares. This 3r plus 2 square minus 3r minus 1 square. What do you get? A square minus b square. A plus b. 3r plus 3r plus a minus b. We go for a minus b first. 3r plus 2 minus 3r minus 1. 3r gone. 2 minus minus 1, 3. Right. A minus b into a plus b. At this 6r, 2 minus 1 plus 1. See, we are very happy with this because exactly same thing in the top, in the numerator. So everything finished. So what you can write now? So if you want, you can write like this. Then you can write UR as this as a 3r plus 2 square minus 3r minus 1 square over 3r minus 1 square, 3r plus 2 square. It's clear? It's clear? Now if you divide individually, this over this, 1 over 3r minus 1 square and plus, not plus, minus, this over this, 1 over 3r plus 2 square. After that, you can tell, otherwise you won't get marks. See, compare with this and tell, so A equals 1, B equals minus 1. That's it. In normal method, if you don't know this technique, what you will do, you will equate this UR to this and cross multiply, equate the coefficient. You can't put the values for R because R is not a fraction, R is not a negative number. So R is always positive integer. So you have to equate the coefficient and get the answer for A and B. Definitely it will A1 and minus. So in this method, this is easiest because I express the same thing here. So you are expressed like this. So A must be 1 and B must be here plus 1, then minus 1. So after that, you have to show that Sn. What is Sn? Sigma R from 1 to n. That is Sn. Okay, shall we do that one also? Okay. I erase this. I erase this one also. So I don't need that. Here, you can say, see. So now you express that QR as a f of r minus f of r plus 1. So if you add by putting u1 and f1 minus f2, and you know we have to write first 3 terms and last 3 terms must mandatory in your final exam. But I'm just writing un first and last only now. Fn minus fn plus 1. So if you add that, this is sigma r from 1 to n ur, and here it will be cancelled like this. No, f2, yes, not like this, like this. So the remaining part f1 minus fn plus 1. So I'm writing, you have to write some other things. So because of the time, I'm quickly writing. So f1 is you substitute 1 for r. What is f of r? This is f of r. So 1 over 1 means 3 minus 1. That is 2 square, 4. Fn plus 1 here, this is fr plus 1. So easily you can substitute n for r. Then easily you can get n plus 3n plus 2 square. That's it. So that's why they ask Sn equal this. It's clear? It's clear? Okay. So hereafter, they talk about the convergence. So I already told you convergent or divergent. If you want to check, this is the formula. That is sigma R1 to infinity UR. If you have value for this, if you have finite value for this, then this is convergent. The series is convergent. If you don't have any finite value for 1 to infinity series, then that series is divergent. So what do you mean by 1 to infinity UR? That means sigma R from 1 to n UR, but limit n takes infinity. N goes to infinity. So this is the definition of this. So you have to find the infinity series, but how to do? We like this. In this case, limit n tends to infinity. What is this? This one. 1/4 minus 1 over 3n plus 2 square. You know, limit n tends to infinity. This becomes 0 because 1 over infinity is 0, right? This, if n tends to infinity, 3n plus 2 all things square always infinity. So answer is 1/4. So don't write like this. Write like 1/4 inside the bracket, finite value. Finite value. Finite value. Then this is convergent. Finite value. So this is convergent. Right? Finite value. Because of that, this is convergent. Do you understand now? So this the way how to answer the convergent and divergent list. And you know, we quickly go to that question whether they ask you to justify this. So sometimes they won't ask justification. Sometimes they will ask the justification. That means you got this answer. Okay, what is the justification? So let's see whether you asking the justification. So I quickly go to the question. The question says, justify your answer. Oh my goodness. Oh my goodness. Oh my goodness. So justify your answer. You have to justify. So how to justify? I erase this. I erase this. I erase this. Okay, guys. If they ask anything like that after in this series, the convergent or divergent anything. So after the convergent, if they ask justify this, then you need to follow this here. Very important thing. That is, you need to know that this is the rule. Limits n tends to infinity, 1 over n that tends to 0. That is 0. So you can use this. This is the basic rule. But from this you have to develop and you have to justify this. Why you put this as a 0? Why you put 3n plus 2 whole thing squared as a 0? So that's a good question, right? Why you put that as a 0? Because we know only 1 over n, when n tends to infinity only 0. So how you can say that is 0? This is 0, okay. But how you can say that is 0? So you need to have the justification, isn't it? So how to do that? See, this is the way. Here, you know that 3n plus 2 whole thing squared, 3n plus 2 whole thing squared, you know, is less than, not less than, no, it's greater than n squared, isn't it? Is it clear? Or n? Or you can put n. Is it clear? Yes, yes. Since this is positive, all are positive, we can write like this. Okay. Do you understand? Do you accept this step? That means 1 over n is always greater than 1 over 3n plus 2 whole thing square. Yes or no? Type quickly. You can forget about this one. Just think about this. 1 over n is greater than 1 over 3n because this whole thing, the big one in the denominator makes the whole thing smaller. 3n plus 2 always greater than n. No? So very smart thing you have to do. If they ask anything, please put like this and less than 1 over n. Just connect with that. And you know this one also. This should be greater than 0 because this is positive, whole thing square. Even though the n is there, that's positive. No, we did this. So this is greater than 0. Now take the limits both sides. Limit n tends to infinity, 1 over n. Limit n tends to infinity, 1 over 3n plus 2 square. Don't take limit here, there is no n, so that is 0. N tends to infinity, 0, 0. Guys, now you know that. Guys, now you know that this is 0. This is the only thing we know. Right? Ah. Now tell me. Ah. Ah. This is greater than 0, less than 0 means that is 0. Okay. So by sandwich theorem, that is our theorem. No? So if other part goes to the, if these two parts goes to the same limit, same number, so limits, the value is that number. Right? So limit n tends to infinity, 1 over 3n plus 2 squared equals 0. So this is the justification. Justification comes like this. So you can do that. So final part is there. With that we will finish. Okay. So what is the final part? They ask something else. Go to that. We go to the question again. Right. See, the last part they asked, this is conversion. Right. This is conversion. Yeah. Finite value. This is conversion. We justified that. Find the smallest value of n belongs to z plus such that Sn minus 1/4 and modulus of that less than 10 to the power minus 6. Okay, we'll do that. That's the easiest one. Any doubts here? Some students are typing. No, no doubts. All just type yes. Okay, guys. Here it is. You have to find the smallest value for n. You have to find the smallest value for n such that this. You know, do you understand here? Sn minus 1/4. What is that? Here, Sn minus 1/4 is minus 1 over 3n plus 2 whole things here. So we can substitute this here for this. Minus 1 over 3n plus 2 whole things here. Don't worry about minus. Modulus is there. Everything will become positive. Since this is also positive, then no problem. So after that, you can release the modulus by just writing the normal one. 10 to the power minus 6. This is positive number. You can cross multiply without any problem. Otherwise, if unique value is there, when you multiply by the minus, you have to change it. When you multiply by the unknown, we are not responsible for that. So don't do that. But if you know solid, if you know the sign solidly, okay, this is plus, this is minus, then you can do. Okay, right. You bring this to down, this 1 over 10 to the power minus 6 and 3n plus 2 square. 10 to the power 6 minus 6 means 10 to the power 6. 3n plus 2 square. Then you take the square root, that's positive. That is 3n plus 2. 3n, this is 1000 minus this, 998. 998 by 3. N should be 998 by 3. That means what? N greater than 998 by 3 means, say 996. That is 3, 3, 2, and 2 by 3. Isn't it? So it says n greater than this one, but we know that since n belongs to z plus, n is a positive integer which is greater than this. What is a first positive integer which is greater than this? Tell me. which is greater than 332.666, and the first positive integer, which is greater than 332.666. What is the answer? Yes, n will be 3, right? 333. Okay, guys. The homework is 2015, 2014. 2015 was the homework that was a repeated question. One answer for maybe 1980, 98 or somewhere else it came that. So they put again in 2015. Similar question. Exactly. Right. So do 2014, 15. So 13 is done. And 17 also hereafter you can. Okay, guys. I think it's a good time to conclude the class. And today is okay. So special method and one more class to uh, wind up everything in series. Okay, guys. Good night. Bye. Yes, good night.